Hey everyone, and welcome back to the channel. Today, we're embarking on a mind-bending journey, a cosmic detective story that spans centuries. Have you ever looked up at the Milky Way on a clear night and wondered, where exactly are we in all of that? It's a question humanity has pondered for millennia, and finding the answer is one of the most incredible tales in science. For a long time, we thought we were at the center of everything, a belief that made perfect sense from our limited perspective. But as our understanding of the universe grew, we realized just how far off we were. So grab your metaphorical telescopes, because we're about to uncover how we finally pinpointed Earth's cosmic address within our magnificent home galaxy, the Milky Way. Before we zoom out, let's set the stage. For centuries, our view of the cosmos was geocentric. Earth was the immovable center, with the sun, moon, planets, and stars all revolving around us. This idea was championed by ancient Greek philosophers like Aristotle and Ptolemy, and it dominated scientific thought for over 1,400 years. It felt intuitive. We didn't feel like we were moving. If you stood outside and watched the sun rise and set, it certainly looked like it was orbiting us. And the stars? They appeared as tiny pinpricks of light, fixed to a celestial sphere, slowly circling overhead. This geocentric model was deeply ingrained, supported by both philosophical and religious views of the time. Challenging it wasn't just a scientific debate, it was a societal upheaval. The first crack in this geocentric armor came in the 16th century with Nicholas Copernicus. He proposed a revolutionary idea, a heliocentric model, placing the sun, not Earth, at the center of our solar system. Earth, along with the other planets, revolved around the sun. This was a radical shift. Imagine trying to convince everyone that the ground they stood on was actually hurtling through space. Copernicus's model, while initially met with resistance, provided a simpler and more elegant explanation for planetary motions, especially the retrograde motion of Mars, which was notoriously complex to explain in a geocentric framework. His work laid the fundamental groundwork, moving us from the center of our immediate planetary neighborhood. However, even with Copernicus, we still didn't grasp the true scale of the universe, or even our own galaxy. The stars were still largely seen as distant points of light on a sphere. It took another generation of brilliant minds to solidify the heliocentric view. Galileo Galilei, with his improved telescope in the early 17th century, observed the phases of Venus, which were only explainable if Venus orbited the sun. He also discovered Jupiter's moons, demonstrating that not everything orbited Earth. Johannes Kepler, through meticulous observation and mathematical analysis, formulated his laws of planetary motion, showing that planets moved in ellipses, not perfect circles, around the sun. These discoveries were crucial, but they still only told us about our solar system. The Milky Way itself remained a fuzzy, luminous band across the night sky, its true nature still a mystery. Fast forward to the 18th century, and the concept of a larger galactic structure began to emerge. William Herschel, a brilliant astronomer, along with his sister Caroline Herschel, made significant contributions. Using a large telescope they built themselves, William attempted to map the stars. He systematically counted stars in different directions across the sky, assuming that brighter stars were closer and dimmer ones were farther away. He believed that the density of stars would tell him how far he was from the center of our galaxy. His star counts led him to conclude that the solar system was located within a flattened, disk-like distribution of stars. This was a monumental leap. It was the first time someone proposed that the Milky Way was a distinct, vast structure, and that we were inside it. However, Herschel's model had a significant limitation. He didn't account for interstellar dust, which obscures our view of distant stars. This dust effectively created blind spots, making it seem like the galaxy thinned out in certain directions, leading him to incorrectly place our sun near the center of his inferred galactic structure. Despite this, his methodology was revolutionary, and he correctly identified the Milky Way as a distinct, disc-shaped entity. He was on the right track, even if the precise location was still elusive. The real breakthrough in pinpointing our location came in the early 20th century, thanks to the groundbreaking work of Harlow Shapley. Shapley was studying globular clusters, dense, spherical collections of hundreds of thousands of stars. He noticed something fascinating. These clusters weren't evenly distributed across the sky. Instead, They were concentrated in one particular direction, towards the constellation Sagittarius. This asymmetry was key. Shapley realized that if these clusters were orbiting the true center of the galaxy, and they were all clustered on one side of our sky, then we couldn't be at that center. We must be significantly offset. To measure the distances to these globular clusters, Shapley used a special type of variable star called Cepheid variables. These stars have a unique property. Their pulsation period is directly related to their intrinsic luminosity, how bright they truly are. Henrietta Leavitt had previously discovered this period luminosity relationship for Cepheids in the Magellanic Clouds. Shapley applied this tool. By observing the pulsation period of Cepheids within globular clusters, he could determine their absolute brightness. Comparing this to their apparent brightness, how bright they look from Earth, he could calculate their distance. It was like having a cosmic yardstick. Shapley's calculations were astonishing. They revealed that the Sun was not at the center of the Milky Way, but rather far out in one of its spiral arms, about 2/3 of the way from the galactic center. His initial estimates for the size of the Milky Way were even larger than what we currently accept, but the fundamental conclusion, that we are far from the center, was correct and revolutionary. Imagine the shift in perspective, from being the center of the universe, then the center of our solar system, to now being a somewhat ordinary star in the suburbs of a vast galaxy. It was a humbling yet incredibly exciting realization. This discovery truly transformed our understanding of our place in the cosmos. It was no longer about a small, Earth-centric universe, or even a sun-centric solar system, but a gigantic galaxy, millions of stars strong, with our solar system merely one small part of it. The Milky Way, as we now understand it, is a barred spiral galaxy, a vast collection of gas, dust, and billions of stars, roughly 100,000 light-years across. Our Sun resides in the Orion Arm, about 27,000 light-years from the galactic center. And we're not stationary. Our entire solar system is orbiting the galactic center at a blistering speed of about 230 kilometers per second, taking roughly 230 million years to complete one full revolution. That's a cosmic year. So, the next time you gaze up at the Milky Way, remember this incredible journey of scientific discovery. From ancient beliefs to telescopic observations, from star counts to cosmic yardsticks, humanity gradually peeled back the layers of mystery to find our true home address in the universe. It's a testament to human curiosity, ingenuity, and the relentless pursuit of knowledge. It reminds us that our perspective is always evolving, and there's always more to learn and discover. What an incredible story, right? If you enjoyed learning about our cosmic address, please hit that like button, share this video with your fellow stargazers, and don't forget to subscribe for more fascinating journeys through science and space. We've got so much more to explore together. Thanks for watching, and I'll catch you in the next one.